All right. Thank you for watching this video. This is going to be a video on algebraic proofs, but leading into this, I'm going to quickly talk about some properties of equalities. Now, properties of equalities are something that if you've been doing math since you were fifth grader, sixth grader, seventh grader, eighth grader, since you learned to add, or since you learned to do equations with an equal sign, you've been actually doing properties of equality. You just might not have called them that. So when you have something equals another thing, there's an addition property that says that you're allowed to add the same number so long as you add that number to both sides of the equal sign. So if I add C to A and C to B, that does not change the equality of this equation because you're adding the same amount to both sides. It would still be equal, right? Same thing with subtraction. So if I have an equation, you're allowed to, based on the subtraction property, subtract the same thing from both sides without changing the equality of it. So you're allowed to subtract 2 from both sides or subtract 10 from both sides. You can subtract the same thing from both sides. And if you do that, it does not change the equality of the equation. And the same goes for multiplication and division. If I have an equation which is two things set equal to each other, then I can multiply both sides by the same number without changing the equality. So A times C equals B times C. I'm gonna yawn. Excuse me. Sorry. My bad. So, right, you can multiply both sides. Now, you can also divide both sides by the same number. Very important, by the same number. So these are properties which allow you to do this, and they're properties of equality. Now, there's also a distributive property that allows that if you have C times, or anything times 2 terms, then you get that C multiplied by them also individually, and that is called distribution, right? C times A and C times B. You distribute C to everything on the inside, and in this case, there's 2 things on the inside because terms are separated by addition and subtraction. So A is its own thing and B is its own thing. So C gets distributed to both, right? So we're going to use those properties to create some algebraic proofs, some 2-column proofs, 2-column algebraic proofs. And I think it'll make sense a little bit more why it's important to understand that these are properties, not just that your teacher at some point in time said, hey, if you're going to add to the left side, add to the right side. You're allowed to subtract 10 from both sides so long as you do it to both sides. This is the reason why, because there's a mathematical property of equality that allows you to do so. All right. Do not ask me who proved these, who created these. I do not know. Some old guy, probably. So we're going to thank him, and we're just going to roll with it. So there's properties that allow you to do this stuff. So what we're going to do is we're going to create some algebraic proofs using this first example. So example 1, we're going to use this equation. So we're going to have x plus 2 equals 3. Well, if I'm creating a t-table, what is the reason that I'm allowed to put this in my proof? It was given to me. That's the reason. It was given, right? Okay, now I want to solve this. So how do I solve this? Well, I personally would take away 2 from both sides. Well, why am I allowed to take away 2 from both sides? Why am I allowed to subtract a number from both sides of the equation sign? Or, yeah, equal sign, equation sign, equal sign. Because of the subtraction property. Subtraction property lets me subtract the same thing from both sides without changing the equality of the equation. So the reason for this would be subtraction property. All right. Now, what is x plus 2 minus 2? Nothing. They cancel out, right? So I just get x. Well, what's 3 minus 2? 1. What did I do there? I did math. And what is it called when we cancel terms out? I simplified it. I simplified it. All right. Now, do I need to keep going? Do I need to continue? Do I need to continue solving this, or did I just solve for x? I just solved for x. So actually, I have finished my 2-column proof. And this over here would be my statements. And these over here would be my reasons of why I was allowed to do what I did over here. Well, I was allowed to write this here because it was given to me. I was allowed to subtract 2 from both sides because of the subtraction property. I was allowed to do the math because I simplified it. What's the reason I have x equals 1? Well, it's because I simplified this by subtracting 2 and got a simplified equation of this. Okay? A key thing to note is after every math operation you do, and in reality this is an inverse operation because we're canceling out, so after every inverse operation we do, you'll simplify. All right? Inverse operation, simplify. Inverse operation, simplify. Okay? So, I like it. But there is a different way to write this. Now, this is, I don't know if you want to call it the lazy way. I certainly don't think it's wrong because if a student did this, I would understand that I would understand their thinking and I would know that they knew what they were doing. But if I were to rewrite this table, and let's put statements, reasons, start from scratch, x plus 2 equals 3. Given. This is another correct way to do this problem, and that is to do x plus 2 minus 2 equals 3 minus 2. And that would still be the same step. That's still the subtraction property. But it looks different. And then the next step would still be the simplification. Oh, 2 minus 2 is 0, so I just get x. Oh, 3 minus 2 is 1, so I get 1. What did I do? I simplified it. Right? So there's 2 different ways to write subtraction property, or to write the actual subtraction, the statement of it. Okay, so there's 2 different ways to write that. Both are correct. One's a little bit lazier than the other, but it's just a different way to look at it. Like, I look at this as, oh, I canceled that out. This looks at it as, oh, I canceled it out right next to each other. All right, you're still doing the inverse operation. It's just a different way to write it. Both are correct. Do what helps you understand. All right, let's move on. Don't want to make this a terribly long video. So if we start with this problem, now I'm not going to do this in two different ways. I'm going to do it in the way that made sense in my brain, or still does make sense in my brain. So we start with our equation. X plus 4 minus 4x equals 13. Why? Because that is given. I don't know how many steps this is going to take, but okay, so what is the first thing we are going to do? Well, I actually have two things that I can combine, and I would say that that would be negative 3x plus 4 equals 13. And I would say that that would be called, you can call it simplifying if you want to. I am going to be more specific and say combining like terms. All right. Now, what is the next thing that we would do? Well, the next thing I would do is I would subtract 4 from both sides. And that would be now usually that would be simplifying or combining like terms, doesn't matter. So this is going to be the subtraction property. And then, right, this cancels out, which is the whole point. I did an inverse operation. I'm trying to solve this, so I get negative 3x equals what? Well, 13 minus 4 is 9. And that would be because I simplified. Not done quite yet. Now I need to divide by 3 on both sides, actually by a negative 3. That would be the division property that you're allowed to, on the division property of equality, divide both sides by the same number. So divide both sides by negative 3. So division property. And that will leave you with, okay, well, that crosses out. And I'm left with x equals negative 3. And that would be simplified. And this would be my statements. These would be my reasons. So these are all the things that I'm stating, right? I'm stating that I have this equation. I'm stating that this is equal to this. I'm then stating that I can combine these like terms. I'm then stating that I can subtract 4 from both sides. I'm then stating that when I subtract 4 from both sides, I get this. And then I'm stating that I can divide both sides by -3. And then I'm finally, at the very end, stating that x equals -3. Right? And the reasons are, I'm given the equation, I combined the like terms, I did the subtraction using the subtraction property of equality, I simplified it by doing the math, I then divided both sides by -3 because I can do that because the division property of equality says I can, and then I did the math and I simplified it and got x equals -3. Okay, these are all the reasons that you've been able to solve equations. If you've just been solving equations, these are the actual reasons that you've been able to. You've been using properties of equality. You've been combining like terms. You've been doing the subtraction property. You've used the division property, okay? One last example. Okay. We're going to start with our given equation, -2 times x plus 3 equals 10. That's given. All right. What is the first thing that we would do? Well, what I would do is I would write -2 parenthesis x plus 3 equals 10, but I would put a circle around this and then over here I would say distributive property, right? That is how I like to show distribution. That's how I like to show distribution, all right? And you don't do it up there because that's you're given the equation and you're given the equation. Here is where you show the distribution. You show the distribution on the next line, okay? Well, now we can simplify. So now we get -2x minus 6 equals 10. And that would be simplified. Okay, next step. Let's add 6 to both sides. And that would be the addition property. And that would cancel out, and I would be left with -2x equals 16. And that would be because I simplified it. All right, next step. Well, I need to cancel out multiplication, so let's divide both sides by -2. Division property. Oh, that cancels out, and I'm left with x equals -8. And I simplified. Right, and I got my statements here. Got my reasons here. Okay, so I had an equation because I was given it. I then distributed the -2 because of the distributive property allows me to. I then simplified, I did the math, I did the distribution, and I simplified it and got -2x minus 6 equals 10. I then added 6 to both sides because the addition property says I'm allowed to, and it doesn't change the equality of it. And then I did the math. I added 6, and I got -2x equals 16. I simplified it. I then needed to cancel out this pesky multiplication out here, and to do that, I divided both sides by -2 because the division property says I'm allowed to do that. And then I did that, and I got x equals -8, and that is because I simplified it. Okay, that is algebraic proofs. Okay, that's how you break them down. You have the math that you would usually do step by step, one step at a time, and then the reason for each step broken down. Okay, you proved it. You proved that x really does equal -8 using mathematical properties and math. Okay, I hope this video was helpful. I hope that made sense. Thank you for watching.